Okay, today we're going to use what we've learned so far in this unit and do some algebra with it. So if we are given this picture and we're told that the measure of angle ZYU is 5p squared minus 5p minus 8, and the measure of angle UYW is 4p squared minus 3p plus 7, and we're asked to find this angle. Well, looking at our picture, we're told that these two angles are congruent. So that must mean that YU is the angle bisector. So if the angles are congruent, then we can set them equal to each other. So set angle ZYU and the measure of angle YU, YW equal to each other, and subtract 4p squared from both sides, and add 3p to both sides, and subtract 7 from both sides, because remember, if you see a square, that's a quadratic, so that means to get everything over here on one side and set it equal to 0. Now you've got p squared minus 2p minus 15 equal to 0. So we're going to factor that. So we're going to factor it into what are multiples of 15 that when added or subtracted will give you 2. Since it's a negative, we know one of them is going to be positive and one's going to be negative. So if we look at it, 5 and 3 are multiples of 15. You multiply those together, you get 15. And since our 2 is negative, we want the big number to be negative. So this would factor into p minus 5 times p plus 3. And if that's set equal to 0, then we know that p must either be 5 or negative 3. So we're asked to find the measure of the angle. We've got two variables to try. So let's just try both of them. So if we use that x equals 5, we use that one, and put that in for 5p squared minus 5p plus minus 8, then we end up with this equation. 5 squared is 25. 5 times 25 is 125. 5 times 5 is 25, and then we still have our minus 8. So you put that in your calculator, and you get an angle of 92. Well, even though that doesn't look like a measure of angle 92, I've told you not to go by what the picture says, so that may very well be a measure of 92. So let's try putting x equals negative 3 in. So put it in the same equation. 5 times negative 3 squared minus 5 times negative 3 minus 8. So you get 5 times 9 plus 15, because a negative times a negative is a positive, minus 8. And then if you put all those together, you get an angle measure of 52. So it's either 92 or 52. But if you actually think about it, if the measure of ZYU, if that were 92, then that would mean this would have to be 92, and adding those together is going to be greater than 180, and you can't have angles sum of a triangle be greater than 180, so that actually isn't going to work for us if you think about it. So you have to make sure that your answers make sense. Okay. Now we're given that FC is an altitude of triangle BCD. Okay? If it's an altitude, then we know that it is from the vertex perpendicular to the other side, so we know that that is a 90-degree angle. I already marked that in the picture. And if we're told that the measure of angle CFD is 12A plus 45, then all we have to do is set that equal to 90. Solve for A. Subtract 45 from both sides, and you get A equals 3.75. Okay, now let's do our next one. You have the picture? Yeah, I'm covering up the picture too. Okay, so given that, and this should actually not be a negative there. Okay, we're given this picture, and we're given that WA is 3 times x plus 12, and that AK is 10x plus 1. And we're asked to find the value of x. Well, the picture shows that this segment is congruent to this segment. Also shows that this line is perpendicular to this line. So this isn't named, but this line, this segment here, is the perpendicular, because it's 90 degrees, bisector of this segment WK. All right, so if WA is congruent to, if the measure of WA equals the measure of AK, then we just set those equal to each other. Okay? Distribute your 3, get 3x plus 36 equals 10x plus 1. Subtract 3x from both sides, you get 7x. Subtract 1 from both sides, you get 35. 7x equals 35. Divide both sides by 7, x equals 5. Okay, then we're asked to find WK. Well, we really only have to find the measure of one of them and multiply it by 2, since these two are congruent, right? So let's find the measure of WA with x equals 5. Simply put 5 in for x there, so it's 3 times 5 plus 12. 5 plus 12 is 17. 3 times 17 is 51. So that's WA. And so if we know that WA is 51, then we know that AK is also 51. So you just add those together, and WK is 102. All right, now we've got another triangle. Let's see how much I can cover up. I'm giving it away. Okay, it's hard to cover up. Okay, we're given this triangle, and we're given that JU is congruent to UM. The measures are the same. So to find the value of x, we just set those equal to each other. Okay, solve for x. So add, we've got a quadratic again, so you need to get everything over to one side and set it equal to 0. So add 6x to both sides. 6x plus 4x is 10x. Add 13 to both sides. 3 plus 13 is 16, and set it equal to 0. So now, to finish solving for that, you need to factor this. So you look for multiples of 16. What times what will give you 16 that when added or subtracted give you 10? Well, this is a positive 16. So both of these are either going to be positive or negative. If you look at 2 and 8, 2 times 8 is 16. And when you add 2 and 8, you get 10. So it can factor into x plus 2 times x plus 8 equals 0. So that means our x is either going to be negative 2 or negative 8. Okay, that's all we were asked to do, is find the value of x there. So now, if we're asked to find JU, okay, JU is here, so we need to use these values of x to find JU. So if you use x equals negative 2 and put it into this equation, negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is 4. 4 times negative 2 is negative 8. And plus 3, that's going to actually give you 7 minus 8, which is negative 1. And you cannot have a negative length of a segment. So that means that x cannot equal negative 2. Well, let's double check x equals negative 8. You put negative 8 in, negative 8 squared is 64, plus 4 times negative 8 is minus 32, plus 3, and that equals 35. So that's going to be a valid length of our segment. Okay, and JM, the whole thing, is just 2 times JU, right? If they're both the same, it's JU plus UM, and UM equals JU. So you just put in what you just found for JU, 35, 2 times 35 is 70. Okay, now we're going to have to think about this one. We're given these 3 coordinates, and we're asked if F, this point, lies on the perpendicular bisector of this segment, DE. Now, what we know about perpendicular bisectors is that they are perpendicular to the segment, and it goes through the midpoint. So we need to find the midpoint of DE, and then we need to find the slope of DE and see if F, the line that goes between F and the midpoint, is perpendicular to it. Okay, so let's call that G. So if I can draw this, let's say we have DE here, and I'm going to find the midpoint G, and we're wondering if F is out here somewhere, if this is on the perpendicular bisector of DE. Okay, does that make sense? So let's find the midpoint, let's find the coordinates of G given DE. So remember the midpoint formula, you add the x's, divide by 2 for your x coordinate, add the y's, divide by 2 for your y coordinate, and we get that G is going to be 5, 1.5. Okay, so now we can find the slope, what the slope of this segment is. Remember, slope is rise over run, the difference in the y's, so 2 minus 1 over the difference in the x's, 7 minus 3. And notice that you always have to go in the same direction. If I subtracted this one from this one, then I have to subtract this one from this one. Okay? So 2 minus 1 over 7 minus 3. So that's 1 over 4. So the slope is 1/4. Now if we find that this slope is the opposite reciprocal, which will be -4, right, the perpendicular slope, then we could say that F is on the perpendicular bisector. Well, let's figure it out. So we need to find the slope. We've got the two coordinates. Here's G and here's F. So the slope is 5 minus 1.5 over 4 minus 5. So that's going to give us 3.5 over -1, which is -3.5, and that is not perpendicular to DE. So that is not on the perpendicular bisector of DE. Okay, now we're given some other points and asked the same question. Does Z lie on the perpendicular bisector of XY? Well, let's let A, name some point A, be the midpoint of segment XY. So find what the coordinates of that A of the midpoint would be. Okay, add up the Y's, 1 plus 7, divide by 2 for the X. Then add up the Y's, I meant add up the X's, excuse me, for the X, and divide by 2. Then add up the Y's, 2 plus 2 divided by 2, you're going to get 8 divided by 2, and 4 divided by 2, which is 4, 2. So that is our midpoint coordinate. Okay, so again, let's find the slope of XY. That's going to be the difference in the Y's, so 2 minus 2, and 7 over 7 minus 1. 2 minus 2 is 0 over 6, so our slope is 0. And that's actually going to be a horizontal line, right? Now the perpendicular slope to 0 is undefined because that's like 0 over 1. It's actually 0 over 6. So if we were to take the opposite reciprocal, it would be -6 over 0, and that's undefined because you can't divide by 0. So that's going to be a vertical line. So let's see if we get that as our slope of Z of AZ. Okay, here's our coordinates for A, here's our coordinates for Z. So 6 minus 2, the difference in the Y's, over the difference in the X's, 4 minus 4, which is 0. So we get 4 over 0, which is undefined. So yes, we know that it is perpendicular, and that's the midpoint. So it is, Z is on the perpendicular bisector of segment XY. Okay, now we're given some information. We're given this picture. And looking at the picture, we can tell that WY is the perpendicular because it's perpendicular to bisector, because it cuts it into two congruent segments, of xz. Okay, you see that? Okay, so if we're going to find xv, and we're given xv, we need to find x. Well, we know that xv and vz are congruent, so set those equal to each other. Solve for x, and you get x is 5. Okay, so put 5 in for x for the formula, the expression for xv. xv is 10 times x, so that's 5 minus 2 is 48. Now we're going to do something similar to find wz. Okay, well, first of all, we're given wx, but we're not given anything for wz, so we're going to have to find some kind of relationship. Well, if you look, we've got side and angle, and then they're on the same line, so that means that this is also 90 degrees, and then this is congruent to itself by reflexive property. So we have side, angle, side, so we can say that this triangle is congruent to this triangle. So triangle WXV is congruent to triangle WZV. So that's by side, angle, side. So we know then that WX is congruent to WZ because of CP/CTC, corresponding parts of congruent triangles are congruent. So we can just use this formula, this expression, 10x plus 7, to find WZ as well. We're still using x as 5, so put in 5 for x. 10 times 5 is 50, plus 7 is 57. So now it asks us what kind of triangle is triangle WXV. Well, it's got a right angle, so it's a right triangle. Okay, now we're given another triangle with sides PS and RS for us to find the value of x. So we can set PS equal to RS. So set those up, do the math, subtract x squared from both sides. You get x squared over here. Add 4x, 4x minus 4x plus 4x is 0. Subtract 5, 5 minus 5 is 0. And you're left with x squared equals 0, therefore x must be 0. So then just put 0 in for PS. 2 times 0 squared is 0, minus 4 times 0 is 0, plus 5, so you're left with PS is 5. So what kind of triangle is PQS? PQS? Well, it has a right angle there, so that means it's a right triangle. Okay, now we've got a figure here with lots of stuff going on. Let me erase this first. Because the only reason I wrote that in there is because of this statement. If MS is an altitude of this triangle, that means it goes from the vertex perpendicular to the other side. That's how I knew that was a right angle, because MS is the altitude. Okay, we're given the measure of angle X is this expression, and the measure of angle, angle 1 is this expression, and the measure of angle 2 is this expression. Now, since these are on the same line, we know that angle 1 and angle 2 must be complementary, okay, because these have to add up to 180, and if this one's 90, then this one must be 90. So the measure of angle 1 plus the measure of angle 2 must equal 90 degrees. So set it up that way. You have to add these together. So you put all of this, measure of angle 1, plus the measure of angle 2, set it equal to 90. Combine your like terms. You have 2x squared minus x squared, so you've got x squared, 7 plus 5x, 12x. 77 plus 40 is 117. Well, again, we've got the x squared. It's a quadratic, so you're going to need to put everything over on one side, set it equal to 0. So subtract 90 from both sides. You can have x squared plus 12x plus 27 equals 0. Now you need to factor that. So let's come up here. So now look at what factors of 27, when added or subtracted together, give you 12. Well, let's try 3 and 9. So it's positive, so both of these are going to be positive, and this is positive, and if you add 3 and 9, you get 12. So this factors into x plus 3 times x plus 9. Is that equal to 0? Then x must equal either negative 3 or negative 9. So we're going to have to try each of those because we're asked to find x. So we found x. It's one of these two, or it could be both, and the measure of angle 2. So let's try x equals negative 3. Put it in for the measure of angle 2. 2 times x squared plus 7x plus 40. Put negative 3 in for x. 2 times negative 3 squared plus 7 times negative 3 plus 40. So that's 9. 7 times negative 3 is negative 21, and then plus 40. Add those together, you get 37. Okay? Now we need to try x equals negative 9. So the measure of angle 2 with x equals negative 9, just put x in for negative 9 in for x. So negative 9 squared is 81, 2 times 81, and negative 9 times 7 is negative 63 plus 40. And when you add all those up, you get 189 for a measure of an angle in a triangle, and that's too big, so that's not going to work. So we know that x does not equal negative 9, it must equal negative 3. Okay, now let's look at the situation where ms is the median of the triangle. Okay, so if it's the median of the triangle, then we know that that you can set QS, because it goes to the midpoint, okay, from the vertex to the midpoint of the other side, then QS is congruent to SN. So you can set their measures equal to each other. 3a minus 14 equals 2a plus 1, and you get a equals 15. Okay? So then we were asked to find the value of a. We did. Now if ms is an altitude, and this is for this problem, okay, then that would mean if it were an altitude in this problem, then this measure would be 90 degrees. Okay, we're given that MSQ, this angle, is 7a plus 1. So we just found a, so let's put that into our measure for angle MSQ. 7 times 15 plus 1. Well, that's 106. So it's not an altitude because that angle didn't equal 90 degrees, so that means it's not perpendicular to it. Okay, now let's look at this diagram. Okay, we're given that these two are congruent, so we can set those equal to each other to find x. Okay, 5x minus 18 equals 2 times x plus 3. Okay, distribute your 2, you get 3x equals 24, and divide both sides by 3, get x equals 6. Okay, so now you've got x. You can put x in to find the perimeter, and that should be 4x plus 1, not 4x minus 1. Okay, we want the perimeter of our triangle, so we need to find the length of all three sides of the triangle and add them together. So Rn is 4x plus 1, so put our x in for that measurement. Okay, 4 times 6 plus 1 is 25. Ru is 5 times x minus 1. So x is 6, 6 minus 1 is 5, 5 times 5 is 25. Okay, and Nu is this whole thing, so it's No plus Ou. So just put x in for that. So it's 5 times 6 minus 18 plus 2 times 6 plus 3. You get 2 times 9, which is 18. So 30, 5 times 6 is 30, minus 18 plus 18, you're left with 30. So the perimeter are all three of these sides added together. 25 plus 25 is 50, plus 30 is 80. Okay, so what kind of triangle are you in? Well, if you noticed, we had two congruent sides right here. RN, RU, and RN were the same length. So it's an isosceles triangle. All right. Now, let's look at this one. And we're given, it's not written on your thing, but Y, this intersection here, is the centroid of this triangle. So that means from the vertex to the centroid is 2/3 the length of the whole segment. Just to let you see, this is a segment divided into thirds. So this is 2/3, and this is 1/3. Then note that this segment is 2 times this segment, and we'll use that here. If we try to find, we're given that RY is 8. I've got that marked here. If RY is 8, well, that's 2 times YG. So YG must be 4. Okay? And then the whole segment is 8 plus 4, which is 12. Okay? NT, so from here to here, the whole thing is 81. So to find NY is going to be 2/3 of NT, or 54. Okay? And YT is going to be what's left, or 1/3 of the whole thing. So 1/3 times 81, or 27. Okay, now IY is going to be 1/3. It's going to, we're looking for SY, sorry. So SY is from the vertex to here is going to be twice the distance as from the centroid to the other side. Okay, so we find SY is 2 times IY, or 2 times 4.5, which is 9. And SI is just going to be the two segments added together. SY, which is 9, plus YI, which is 4.5. So that gives you 13.5. Okay, and our last slide today is to determine the markings, based on the markings, excuse me, to see what kind of line AB is. Should be segment AB. Well, if you notice here, AB forms a 90-degree angle if you extend that side out. So it is perpendicular to the other side. So from the vertex perpendicular to the other side is the altitude. Okay, and here, AB, by the markings, these two angles are congruent, so it bisects that angle. So it's the angle bisector of that triangle. Here, AB, again, forms a 90-degree angle with this segment, so it's perpendicular to it. So it's the altitude. It's from the vertex perpendicular to the other side. That's the altitude. If you have a right triangle, the altitude is always going to be the legs of the triangle. Okay, and that's it. I hope that gives you enough so that you can work on the worksheet in class tomorrow.